In this experiment, we tested how freezing objects affects its velocity and acceleration when dropped from 19 feet off the ground. The materials that we used for this project were 2 apples, 2 slippers, 2 tennis balls, 2 socks, a notepad, a camera, and a stopwatch. To explain our thought process, we dropped 4 objects off a balcony with negative displacement of 19 feet to the ground, recording their times while mid-air. Then we froze those same objects and tested all the same measurements.
We decided to perform this specific experiment because we wondered whether objects that had a condensed mass and added frost and ice to the surface would fall the 5.8 meters any faster than the normal objects. To conduct this experiment, we took 1 tennis ball, slipper, sock, and apple and left them to freeze overnight. The following day, all 8 objects were dropped off the designated 19-foot drop while their air times were recorded to our notes. The variables of this experiment consisted of the independent variable, which was the object being dropped, whether it was frozen or not, the dependent variable, which was the time it took the object to reach the ground, and the constant variables, which were the distance being dropped above the ground, which was 5.8 meters or 19 feet, the location, which was the same balcony of the gym, and the same person dropping the objects and recording the times. While testing all 8 objects, we measured the displacement, final velocity, air time, as well as the initial velocity, which, because they were dropped, was always 0 meters per second.
Since we dropped all objects from the same balcony, the displacement was one of our constant variables at 5.8 meters or 19 feet.
The frozen objects seemed to reach the ground very slightly quicker comparative to their non-frozen counterparts, only by about 1/10 of a second. If we were to do any further research into this topic, it would be to pinpoint the exact reason why this is, whether it's due to the condensed mass or the added weight from frost and ice. The average air time of the 4 non-frozen and frozen objects was calculated by adding the 4 sums of the air times, say W, X, Y, and Z, dividing all by 4 to calculate the average time. In this case, 1.26 seconds for the non-frozen objects and 1.17 seconds for the frozen. As we had initially predicted in our hypothesis, the added mass to the frozen objects caused them to gain velocity mildly quicker than the normal objects because of the principle of mass conservation.